Hi class, so let's have a few more examples of actually loaded compression members. For the following problems, we will not check whether the section has slender or non-slender elements. We'll assume there are no slender elements for now. However, it's important to remember that in real design, we must always check for slender elements because if a part of the section is too slender, it may buckle locally. So, imagine nyo na lang yung lata. Pagka sinabing local buckling, ibig sabihin may parts lang or elements lang yung nag-bend. So, that's what we call local buckling. Pagka global buckling naman, yung entire section yung nag-buckle. So it means that some parts of the section start to bend or wrinkle even before the entire member buckles globally. So that's why this check is important. It ensures that this section can develop its full strength safely without early local failure. So let's have the sample problem. Find the maximum axial load that the W200 by 46 column can safely carry if its effective length is 6 meters. Fy equals 248 MPa and E equals 200 GPa. Use ASD for design philosophy for this example. So the given effective length is 6,000. So take note that effective length is also equivalent to KL. So you have to convert it to mm. So this becomes 6,000 mm. So no need na to get the K since yung giniven na, buo na binigay yung effective length na KL. So that is equivalent to 6,000. Lagay ko lang dito yung term nito is also known as effective length. Next is to get the ratio of KL and the radius of gyration R. So 6,000 over 51.1 is equal to 117.417. Then we have to compare it to 4.71 for us to determine kung saan siya mag-fall if it is inelastic buckling or elastic buckling. Kung condition 1 or condition 2. So 4.71 square root of E 200,000 for the steel. Then the given Fy is 248 to get 133.755. So this means that it is less than. So this will fall to condition 1 in elastic buckling. So to determine the FCR, we will use the formula 0.658 Fy over Fe times Fy. We have to solve first the Euler's critical buckling stress. Pi squared E over KL R squared. So pi squared 200,000 times 200,000 over the ratio. So we'll have to rewrite it in the formula 117.417 squared. So Fe is 117.417 squared is 143.175 MPa. So I have to store it to variable A para madali natin makompute yung FCR. So 0.0658 Fy248 divide Fe 143.175 times 248.658, 248 times 248, we get 120.114 MPa. But in the problem, we have to get the maximum axial load using ASD. So what we need is the P. So P is equal to AG times FCR. So the area gross is 5,860 times 120.114. So 5,860 times 120.114 is then divide it to 1,000. Para makuha natin is in kilonewton. So 703.868 kilonewton. Then apply the ASD. Divide it by safety factor of safety factor of 1.67 as per NSCP. 1.67, so 421.478 kilonewton. Next, a W310 by 118 section with a length of 8 meters is used as a column. Determine the safe axial load that the column can carry using AISC specifications with Fy equals 345 MPa when column ends are fixed. Pag column ends are fixed, K is equal to 0.5. For letter B, one end of the column is fixed and the other is free, so 2.0 as per NSCP. So we have to use the LRFT as a design philosophy. So to solve this one, get the ratio for letter A. So 0.5 times the length of 8 meters, so 8,000 mm over the radius of gyration. So yung kukunin natin, yung recommended value for the radius of gyration is the smaller one kasi siya yung makakapagbigay ng larger value for this ratio. So we get 77.6, so 0.5 over 77.6, so 51.546. Then you have to compare it to 4.71 E over Fy. So 4.71 square root of 200,000 over 345. The given Fy is 345, 113.403. So less than pa rin yung ratio nito. This will fall as inelastic buckling or in condition 1. So we have to use FCR is equal to 0.658 Fy over Fe. Fy, solve first the Fe, pi squared times 200,000 over KL over R. So ito yung solve natin dito. So 51.546 squared. Ito yung general formula ng Fe. So equals to 200,000 over 51.546 squared, 742.916 MPa. For the value of FCR, 0.658 raised to Fy over Fe, 345 over Fe. So we start the value of Fe in variable A times Fe 345 so equals to equals to 284.057. Then to get the actual load, Pn is equal to Ag times FCR. The given gross area is 15,800. Then from our previous solution, we get FCR 284.057. So 15,000 times FCR, so equals to, then divide it to 1,000. So 4,260.857 kilonewton. Then applying the design philosophy LRFD, so we have to multiply it by the reduction factor 0.90 or 260.857, so equals to 3,834.771 kilonewton. This time, the ratio KL over R is equal to the given K as per the given support is 2 times 8,000 over K, 77.6. So 2 times 8,000 over 77.6 is equal to 206.188. Then comparing it to the 4.71, so pareho lang yung ginamit na mga variables na E200. Yung Fy natin is also equal to 345. So gagamitin din natin itong value to compare for this ratio. So 113.403. So we can conclude this is greater than. So mag-fall po siya sa condition 2 as elastic buckling. Pero sa NSCP provision po, hindi na inaalaw na lumampas sa 200 yung ratio nito. Kaya yung gagamitin pa rin natin na slenderness ratio is 200. Kasi as per NSCP. So this time, the FCR is equal to 0.877 Fe. So to solve Fe, so pi squared 200,000 over KL over R. So we will use the 200 limit po para dun sa slenderness ratio as per NSCP provision. So pi squared 200,000 over 200 squared, so equals to 49.348 MPa. So I will store it. So 0.877 times Fe is 43.278 MPa. Then to get the actual load, Ag times FCR is times natin sa area gross yung FCR natin. So, area gross is 15,000. Then, divide it to 1,000 para maging kilonewton. So, 649.173 kilonewton. So, mahina na po yung strength pagka pumapasok siya sa elastic buckling. So, hindi niya na nare-reach yung full capacity niya. So, masyado nang mahaba yung column. Hindi pa to, since we need to use the design philosophy. So, times to reduction factor, 0.90 times 649. So, mas hihina pa siya. Times 0.9. So, 584.256 kilonewton. So, this is the final answer.